Hey guys, Brad here with another video. This is a little different from my norm. This box just came in. It's a Sinistar sound speech board. I think the volume pot's probably in here too. This was sent in from Tinjuna on Clav. Posted, changed out some caps, trying to recap it, put it back in. Some smoke came out, doesn't work now. Different folks making suggestions on things to try, check, to see if caps were in backwards, those sorts of things. Didn't really get anywhere, so I said, send it in, we'll do a video and figure out what's wrong. So here's the box. Just came in to me. Customer, I'm folding his name up here, sent me a little note, which is always nice, kind of explaining what happened along the way. And we'll open her up here. Got the, this is an original volume pot. I'll test that out. I'll test it statically with an ohm meter, and these are typically 5K pots, and then under load when we get the board working as well. Static bag, which is nice. Flip this over, put it on the box. How's that? They did send a ribbon cable. I've seen these ones before. I make my own up. They're all NOS 3M parts. These ones typically aren't, and I tend to not use the board end, the board to wire end here that goes in. I'm able to remove these without damaging probably 80-90% of the time, and then I'll make it the correct length. So let's take a quick look here, see if we see anything. I'll hold it up a little higher to the camera so you can see we've got. There should be about 8 new caps, 9 on here. So this is the large 4700 microfarad, and I can see that the plus is where it should be. This one is a negative, so this plus should be over here, which it is. You can see the arrow pointing towards negative. 100 microfarad here pointing towards ground. That's good. Solder's a little blobby. Probably just iron wasn't hot enough or have a hot enough iron. That's pretty normal. I see that a lot. I'll reflow these and clean them up. You've got the 7805 voltage regulator here. Oops. It's got the gold legs. You can tell it's a nice old one. I like those ones. I will pull these bolts out and put new heatsink compound, clean out the old stuff. I do it also on the TDA 2002 audio amplifier here. I'll put new heatsink behind that, clean it up. I'll pull the fuses out, recrimp these little friction fit guys here. I'll clean with some 3M Scotch-Brite pad the fuse itself and get it back in. These two over here on the output section, you got a 470, which is negative, and that one's in the correct way, and so is this one. And then there's a little decoupling one up here. I tend to read this a 10 microfarad. I put a tantalum in on these. I'll probably replace that as well. These are 1 microfarad decoupling caps, one for the CPU, one over here off the bus, and then another one here. They're all installed correctly, so all the caps are in right. The one thing I do notice, I don't know if this was just done for shipping, but the ribbon cable here, you can see, is actually offset. It's not on the 2 rows of pins here. It's only plugged into the one. You can see the connector hanging out the back there. So if I pull that off, oh boy. Yeah, it was only plugged in on this back row of legs, which would have been on the front row of teeth. So that's very possible that if that was plugged in that way, that would have caused a problem for sure. The board. When you have the Sinistar board, there's a jumper here, W1. It's cut right now. What that does is it forces the audio as it leaves the D to A converter here, and it goes out through the 40-pin ribbon cable to the speech board. If there's speech, it gets integrated with it through some little amplifiers, and then some op amps, and then comes back over to the main primary amplifier here. So the board won't work even unless you jumper or put a speech board in if that jumper's out, or you can just put the jumper in, or just clip to it. So I will get this on the bench. I'll put a bypass in for the speech board to start with, and we'll do some diagnostic work on here with the FPGACatBox, and I'll check a couple voltages right away with a meter, and we'll do a couple other things. So that'll be in the next video. I'm going to pause this one, and we'll come back to you. Okay, here we are. Got this set up on the bench. It's actually the next day, thanks to the magic of movies here. It's probably seamless for you. So here's the soundboard. Here's the speech board that came in. And again, this was plugged in with this ribbon cable offset. And again, I'm not sure if that was just plugged in while shipping or if that's the way it was after the recap happened on the main board. I'm kind of leaning towards that was the root cause of the problem. What I did is I looked over the schematics and just to see here what would have happened if that were the case. And unfortunately, the way the cables work here, these pinouts, is the top row is basically 1 through 19, all the odds, and the bottom row is 2 through 40, incrementing. And so if you looking at the drawing here, pin 1, I don't know if I can get that over here, shows the plus 5 volts analog on pin 1, but pin 2, which is normally getting the 5 volts, which powers all the ICs and everything, right? So pin 2, which is what that was plugged into inadvertently, pin 1 is the minus 12 volts. And, you know, if you had a switcher, it might be minus 5, but it's still a negative voltage, which is not a good thing. On the speech board, you know, you've got a couple of these 1458 op amps here. Oops, the focus is pretty bad right here. And these op amps typically are pretty sensitive. These have two amps in each one. I think there's one unused on the board. And then this guy back here is the 55516 or 32 or whatever it is. The CVSD, the constantly variable slope demodulator. This is what takes the raw data from the speech chips and creates kind of an analog output that goes into 2 stages of one of the op amps here. So I'm worried about, if that were the case, the EPROMs could have been damaged, capacitors, electrolytics, they're polarized, so if we fed it a negative could be suspect, as well as this guy here. So potentially a few capacitors, the 2 amps, the CVSD, and the EPROMs could be hit. Or everything could be good. We don't know. So on the bench here is the board. I've got a little Bose speaker I keep on my test bench. I also have one up that I use when I'm playing the games, but that's here. And then I do have a power hookup. I can run that in here. We'll do power. I've got a dedicated 5K pot I use on the test bench here. I actually have a couple of these made up. I'll plug that into the pot. This is the end of that Bose speaker here, little 4-pin Molex. I'll plug that guy into where the speaker goes. And unfortunately on Sinistar, the original EPROM, the test mode did not work. And Cinemax had modified that code, and not only did he add the sound test back like for Stargate and Defender and those ones, but we went back after some discussions and he added the ability to test all the speech as well. So what I'm going to do here, just for the sake of argument, is I'm going to remove this original Sound ROM 9 that has no ability to run a self-test. Now normally what I'll do is I'll hook into here and I have a little manual tester. I actually have an automated one too where I can run all the sounds, but I'm just going to use this as one of the modified Sound ROM 9s. So based on that, now we have power, speaker, volume, and the test ROM. But ideally, I don't want to run it with this speech board right now. I want to isolate this board. And there's a jumper on these boards when you run speech that you remove. So what I'm going to do, I've got a little jumper cable here, and I'm going to bypass that jumper essentially. So normally the audio that's generated here, the analog, goes out to the 40 pin when the jumper's cut. Routes through, gets amplified and mixed with the speech, and then comes back to the main amplifier. Since I'm not using the speech, we just have a little jumper here. So on my bench, I have a remote control, so I'll power it. So now the board's powered, and what I'm going to do is just hit the test button here on the board. There's a little test button. So you can hear that the board's working. So that tells me all the capacitors, 6808 processor, PIA, RAM, everything, amplifier, everything on this board's fine on the actual soundboard itself. Again, I'm still going to go through, I'll probably change these Molex headers, I'm going to change the bridge rectifier, do the fuses, clean up some solder joints, nothing major on it, probably 10 minutes worth of work on it, something like that. So now the next thing would be, let's test it with the speech board and see if it works. So I'm going to pull this guy off the jumper. I apologize for all the beeps on the phone. I think my cameras are triggered. My wife's working in the yard. I've got a little adapter here. This was actually made for a Raspberry Pi. It's a breakout for the 40 pin. So you can plug in the 40 pin here with the female, and then you get 3 rows of males, which I use these. It's easier to unplug the ribbons a bunch of times without having to pry up as I'm testing. But it also gives me a place to connect a scope if I want to look at signals and stuff. So I can have a ribbon cable plugged into a header here and then get in with my scope here. So I'm going to plug in the speech board to this. I did have to modify this. I had to notch these corners out here so they would fit down in. So I'm going to plug that in here, power back up, and I'm going to hit this test again. So that silence you're hearing is normally the speech being driven. So this speech board is definitely not working. So what I'm going to do is stop that. I'm going to remove customer speech board, and I have here one that I keep restored here. I actually have a little note modified using 2732s in December of last year. So I came up with a method. 2532s are hard to source, so I came up with a little way to jumper the boards to run 2732s, which are much more readily available. So I'm going to plug that guy in. I'm going to power back up and then hit this test again.
I am Sinistar. Coward, run, live, hunger, beware.
And then it just loops. So you can see how useful that test is. So that tells us for sure that the soundboard is good, and it tells me my speech board's good, and that the one that was sent is not working. So what I'm going to do next is I'm going to set it up on the bench here with my CatBox Fred Cawthorn makes. So this is the FPGACatBox, and there's different adapters depending on the CPU you use. So this adapter on here is for the 6808, 6802. I'm going to plug it in the board, and we'll be able to test all the RAM and the EEPROM checksums, but we can also read the checksums out of, and we can test the PIA also. There's some other things we can do, but we can read out the speech ROMs to see if they're accessible and working on the other board. And then at that point, hopefully they're good. And at that point, more than likely, the failure is going to be the amplifiers. I'm highly suspect of, but hoping that the CVSD is still intact. We'll see. I do have spares. If not, they're just kind of hard to source. So next video, follow up. I should have this set up on the bench, and we'll go from there. Hey guys, back here. I've got the Sinistar soundboard set up on the bench. I do have my known working speech board, so this is a working setup here. And I also have the FPGACatBox setup here as well. So you've got a USB connection up here. This is a BNC. I'm tapping off a ground here that you can see connected to the ground plane here on the large cap. And then I've got the adapter over here where I'm plugged into, here's the original CPU I removed. This is a 6808. And we're plugged in. So basically the CatBox has full control over the both address and data buses, and can see everything that was exposed to the CPU here. Again, I've got my little adapter here for the 40-pin speech board. We still have the speaker, volume pot, and power. And I'm going to go ahead and power up the board. And then I'm going to switch over where you should now have, see the screen. So here's the software for the CatBox. So I'm going to go ahead and load configuration. I'm going to choose Williams, Stargate, Robotron, and then I have one down here that's a personal one. It says Brad's All Sounds. So I'm going to select this guy, load that configuration. And if we go in here to board config, we can see that it's a 6808 CPU. We've gone through and identified all the potential ROMs. This is one I built where I've got Defender, Stargate, a couple Defenders actually, Robotron, Jaws, Bubbles, Bubbles that's patched, Sinistar that's patched with the one you see here, Blaster, and then we also have the 4 speech chip. So there's a couple ways you can configure this, where you would have it auto detect the board and then it would tell you. I kind of prefer to see everything at once. I think it's a, user's discretion here. Here's the RAM configuration. Again, this is pretty straightforward for this RAM. It's a 6810, and then there's some other stuff. So I'm going to go ahead back to the main screen here where you hit open. So this is going to allow the FPGACatBox to come online, and you can see we have green light and that we've detected the clock, and it tells you what the clock frequency is up here in the upper right. So based on that, I'll go over to the ROM tab, and I'm going to do start ROM test. So it's going through Defender 4K, Defender 2K, Stargate 2K, 4K, all the way down through all the different EEPROM checksums known out there for soundboards. And you can see here, so here's SIO, Sinistar original code, and then I have a SIM, which is Cinemax's modified code. So you can see it finds that IC, passes, and then on my known good speech board, it finds all 4 of the EEPROMs here, which are 4, 5, 6, and 7. So we can see that. And then we can go to the RAM tab, and I can say start a RAM test, and it's pretty quick. It basically writes data into the RAM and then reads it back and verifies it. So you can see all 8 bits responded as expected, and all's good. So the interesting one here under the manual I/O, you can actually write scripts within this tool. So Fred had provided one that we had worked on, and I've modified it a little bit recently. So I'm going to load that up. So you can, basically this is a sequence operation here. So you can define each one of these. You want it to be a comment, read bits, write, compare. There's all kinds of different functionality you can configure. You can specify the address and the data you want, and then you can have comments. And there's also some tricky stuff here you can do, to like this read line here, where you can actually have it write out the results over here, whether it's pass, fail. So basically what this is doing is configuring the ports on the PIA to be able to output a tone file, was initially the function of this. But with once you write out certain values to configure the PIA, with how the ports function, you can also read those values back. So that I figured out was a great way to test these PIA. So I'll go ahead and run this. You should hear a tone. I've still got the little speaker here on the bench, the little Bose. So I'll run this. And you can see as a result, it said read 7F from 400. OK, memory sequence OK. So basically, there's a command here that's write out to address 400 of a 7F, and that's part of configuring the port. And then I do a little pause, and then I read it right back and tell it, hey, the value we should expect is 7F, because that's what we just wrote. And if it is, then you get this OK message. So that tells us here that this board is doing exactly what it should be. If you needed to get into more detail, there's signature analysis, and you can go down to the different ICs and test them. Again, this is a very powerful tool. So I'm going to go back to the setup screen. I'm going to close. I'm going to power off the board, so there's no power. And then I'm going to swap out this known good speech board with the original one that was sent in. So again, the hopes here are that we're able to get checksums out of these 4 2532 EEPROMs. So they're back on. I'm going to power it up. And then open the port. We're waiting for the green lights here. And both of them are detected, and the clock is still good. So I guess we'll go right to it. I'll go to ROM. We'll hit start ROM test. There's the one on the board, the main board, and there are all 4 of the speech ROMs on the speech board. So that's great news. So again, I'm leaning towards on the speech board over here, probably being the op amps bad, probably both. If they both got hit with that negative voltage, I'm going to check and replace. So my plan is I'm going to replace this ribbon cable. The customer did send one in. And then this electrolytic 10 microfarad cap here, I'll replace. Let me switch over here so we're not seeing the screen. I can go full screen again. So here's the 10 microfarad cap on the board. There are some other electrolytics, but these are tantalums, and I'll actually replace this with a tantalum as well. And this little tantalum here. So I'll go through and test all these on board, some of the other discrete components as well, the little decoupling capacitors and some fixed resistors. These amplifiers are very inexpensive. Op amps can be a little tricky to test. I can test them with the scope, but I may just swap them out with newer ones. They have a lower noise floor. The replacement ones are a little better model number for op amp. And then we'll come back on the bench and test it again. So I'll see you back here in a few. Hey guys, so I'm back. Got all the repairs finished up here. I'll give you the findings and kind of what we did on the boards. So the last video you saw, the soundboard, everything tested good on it. We had an issue with the speech board. We were able to read the checksums back from the ROMs via the CatBox. Then I took to my bench and did some discrete testing. Turns out that the CVSD, sure enough, unfortunately, was shorted, failed from that negative voltage. And actually the two op amps were still good. So I went through, I changed the ribbon cable, the one that was sent in, replaced that. I did change out here an electrolytic that was here, 10 microfarad with a tantalum, rated at 35 volts. Cleaned it up, cleaned the legs, removed both the labels, re-glued them down. I have a way to remove them without damaging them. And then I polished with I have like a felt type towel with there's a little bit of silicone impregnated in it, kind of used for like cleaning guns and things like that. But I polished whiteboards down and cleaned them up. If they're really bad, I'll put them in a simple green bath and clean them and dry them. And then over on the MPU, which the light on this is pretty bad, but I did put all new Molex headers on it with the square pins. I did go through and reflow and resolder all of the ground plane here for these large caps. I did put a new bridge rectifier in. I did remove the heat sinks here and put some fresh heat sink compound, both for the amplifier and the 7805 voltage regulator. Straightened a few other things up. But overall, didn't need a lot of work here. You can see the old Molex headers here. Here's the CVSD chip, bridge rectifier, cap, ribbon cable. I still have my test ROM in here. Here's the customers. I'll just go through, and I also installed the customer's volume pot because we wanted to test this anyway for them. So I'm going to go ahead and power it up. And then we'll test the...
Sinistar, coward, run, live, hunger, beware.
You can see everything looks real good now. And what I'm going to do is remove this EEPROM that I put in there, mine, put customers back in. And I'll show you how I test on boards that don't have test mode or how I've done it historically. And sometimes if I had a board where someone says, hey, the soundboard will run for like 4 hours and then it cuts out or something like that. So I built a little rig here. This is a Arduino Uno, and I put a little, prototyping board on top, plugs in, and then I've got a wiring harness that goes out over here to the 9-pin header, and this is where normally the RON board is sending the commands on which sounds to play. And I did put a 74LS244 on here. So that way I could load up all the inputs and then shift them in one shot, kind of like the ROM board does it with the PIA. So what I do is I have different configurations for Robotron, Joust, Stargate, and that, and I just load them in via USB. So I loaded the one for Sinistar already, and I'm going to plug that in here. And then basically once the board's powered, and I power this guy up, what it does is it just triggers basically 6 different sounds only. So we're testing all of the digital inputs one at a time, basically, with different combinations. One of them's a speech sound, and we get a couple other ones. So I'll power it up here.
I hunger, coward.
And it'll just loop like that. Unplug it here. So usually what I'll do, again, if you're kind of durability testing, we'll say I'll leave that, I'll turn the volume down a little bit lower, or put sometimes I've used a high watt resistor, 8 ohm, that I'll just leave in circuit to load on the amplifier, and I'll let it run overnight and see if there's any problems creep up. But this board I think is all set. Came in yesterday, is going out today, It's about 3 o'clock in the afternoon, and I probably spent a total, I don't know, with the videos, probably more time on the video than actually working on the board. Maybe 40 minutes or so actually monkeying around with the board and stuff. So it's cleaned up, rock solid. I'll plug the speech board back in. You know, in the customer's defense, these headers, or these 40-pin board headers, they call them a shrouded header. Let me make sure I'm off here. And the whole advantage of having the shrouded and has keys on it and all this, these little grooves cut out, is to prevent the end user from plugging things in wrong. And the problem is with these ones that Williams used is the back side of the header is open. Usually a shrouded box header is fully enclosed and it's keyed, so there's really only one way you can go. Unfortunately, they didn't do that on here, and it leaves itself open for plugging it in wrong. I have seen this before on the ROM board where it plugs into the MPU. Fortunately there, it doesn't cause a major problem. You can unplug it and plug it in the right way, and you don't break anything. But here on the speech board for this, and to be honest, this is the first time I've run into this, yeah, it causes a failure with the CVSD, unfortunately, the hardest to find chip on this whole set. So anyway, I'll get it boxed up, send you an IM, and we'll get this coming back to you. Maybe I'll probably drop it off tomorrow at the UPS store, and you'll have it in a couple days. So thanks for watching the video, and we'll see you guys soon.